Hello guys, Lucas here with another video, and my gosh, I have lined up the camera exactly perfect. I can't believe I've done this. Oh, if I look down, or if I look up, you can kind of see the little tip menu. Okay, so I'm doing something a bit different. Right now I am actually inside of a world that I've been working on for quite a while. It's creative, and just ignore these are additional add-ons, but this is supposed to be a display, but it only lights up part of it, and I'm still working on that part. These are other additional things. These are speakers, though, just note blocks that can make noises. And this is a control panel. Okay. So basically, what I've made is a programmable computer. It's only got 5 slots, or 5. Well, I guess 5 bytes of memory. I don't know if that's correct. It can hold up to 5 lines of code, basically. So, right now, I'm just going to delete the memory, so there's nothing in there. Okay, so this here is a shift register panel. So, a shift register is basically a bunch of D flip-flops. Sorry about the background noise. It's a bunch of D flip-flops connected together. So, alright, I'll give you guys a demonstration of this. So this is the input, so I'm going to turn it on, and if I look at my little programming manual here, so 1 will turn the display on, 0 will clear the screen. Okay, so if I go 1, and then I click the shift button, I can do that. So this, I believe, if I'm correct, yep, I'm correct, that will basically turn on the display. So let's hit return, which basically writes that line of code into the memory, and I'll show you the memory over here. So these are the same, they're basically shift registers that I use to make memory. Where is it? One of these things should be off. 1 second. Oh, I think I hit the wrong button. Wow. I think I hit the reset for this. Oh, 1 second. So, I accidentally hit the reset, so let's do this. Make sure that needs to be on. Shift this over. So there we go. Now I click the return button, not the reset button. And then, if I go over here, you see this bit, this one's off, which means this one is basically stored in memory. So, I can turn the display on, and then I'm going to make a noise. Okay. 1 second. I'll be back. Hello guys, Lucas here, and I'm back. My dog is right behind me, sorry. I just plugged in my controller, if you guys seen it die. So, where was I? Oh yes, so it's going to write that to the memory. So now I'm going to play a sound that is... I'm going to make a high sound, okay? So what I do for that, 1 0 0 0. So 1 0. Oh, whoops. Okay. So what I need to do is turn this on, shift it over, turn this off. 0 0 0. I think that's right. Yep. Okay, that's right. So now, if I just press return, it will write this to the little database, or the memory. So now this will play a sound that is high, and this is connected directly up to the note blocks. Now if you guys are wondering, yes, there's a clock. You basically manually press it, and what it does is it shifts it over, like that, and then once it gets to the end, it makes its output. And as you can see, the input here is wrapped around to here. So, or sorry, no, the output of this is wrapped back around. So basically, I can run the program as many times as I wanted to. Alright, so it's gonna turn on the display, and then it's going to turn the display off. So what I gotta do right now is I gotta bring our program to the very top of memory. So right now I need to press return to 2 times, and then so what I'm doing here is I basically 1, 2. So now if you see our program, our very first line of code in our program is right next. It's right next to be activated. So I always have to do that unless I make a program that is up to 4 lines of code. Technically you could do 5, but the program would start right away. So here we go. Turn the display on. So I don't have a proper display, but eventually I will have number codes for each and every individual light on the display. Now next it should ding. Ding. Okay, you guys probably didn't hear that. Sorry about this. Good, you guys can't really see that. So now I gotta... Okay, that's loud. Okay, now let's see. 1, 2... Okay, I gotta press this press it 2 more times. Okay, ready? It's gonna turn the display on, which it's already on, so I'll show you guys that, how to reset it. And now it should ding. Okay, well, what the heck? Oh, I know why. I left this on. So that's another problem, is that I need a manual step, and like it's basically what it's doing is it's basically reprogramming all of that. So what I needed to do was click reset to turn that display off. Sorry about the really loud noise. I'm just gonna fix this. So okay, which one is it? I want it to ding on the next one. So oh wait, I know what I mean. Sorry for the ridiculously loud noise. Okay, I'm just doing a bit of maintenance on it right now. Oh, okay. Well, this video's gone horribly wrong. Okay, here, let me reset this one here, and then I can break that, and there we go. Okay. Right, so on the next button press, it should ding. So that was my fault. I forgot to reset this bit here. That's 100% my fault. It works fine. There we go. And I wouldn't normally have to do that. Well, excuse me, I just burped. I wouldn't normally have to do that, but because I was a bit foolish, I had to. So let me turn the volume back down. Alright, so over here, let me clear my hotbar. Over here is the is an SR latch, so a set reset latch that is connect up to the print and the clear screen. Now, if any of you guys know BASIC, QBasic, print and CLS are the most languages. Some languages are print and CLS, but basically I got that idea from QB64, which is QBasic for a 64-bit version of Windows. So right now it's on this latch. So if I just flick this one here, see how it turned that line off, and the display should be off. Now I could do this written in a program, or I could do it manually. That's why I have the levers there. So yeah, that's pretty much it. And the delete line is actually here, which basically just powers on these torches. Which, well, it powers off this here and powers on those torches, resetting the entire memory bank. So that's pretty much it for the computer. You can't do too much. Yeah. Eventually I'll have expanded memory, but right now I guess Like, this is only just like a starting thing. Eventually I will have way more memory slots, and there'll be more functions that you can do. Yeah. So, I've never really said this in a video, but feel free to like and subscribe and comment. All of your guys' support is really amazing. So far, I've reached 11, I think, ish subscribers, and that's kind of why I'm showing you guys off this video. This is kind of like an important world that I've been working on for a while, because I like doing logic things. And so if you guys noticed, I took a bit of a shortcut with the commands, because if you look at the book, each one of these, so you see how there's a 1 there, the specific, it goes 1 and then it goes 1 0. So basically what I'm saying is that this turn here, I'll show you on the physical lines of redstone. So this one would be turned on to turn on the machine, turn on the screen, and then that would turn off, and then this one would turn on to do that, and then this is another one, and those 3 there are off. So basically it goes, for each command it's basically down the line. So that's not too hard to wire up. As you can see, I just run the wires through. But eventually it's going to get a lot more complicated, because what if I wanted to do something that was 1 1 1, say, or all 1s? It interferes with every single one, because it would write everything to there. So that's where logic gates come in handy. So I have done a quick little showcase of them. So this is a NOT gate. If the input is 0, the output is 1. If the input is 1, the output is 0. So input is 0 or off, I get an output of on or 1. So if I turn this one 1 or on, I get an output of 0 or off. So it's basically the opposite, or not the input. Here I have an AND gate, so we'll call this input A, input B, and output. So if input A is 0 and input B is 0, I get an output of 0. If input A is 1 or on, and if input 1 is on and input 2 is off, then I get an output of 0. If it's the opposite, so input 1 is 0, input 2 is 1, I get an output of 0. But only until both of these levers are pulled, I get an output of 1, or on. So on, you get an output. Anything else, you don't. This is a little OR gate. Now there's better ways of doing this, but it's basically just redstone connecting each other. So if this one is on, I get an output. If this one is on, I get If this one's on, this one's off, or this one's off and this one's on, I get an output. If both of them are on, I get an output. So basically, it doesn't matter whatever lever you pull in any seat pattern, you'll get an output. So this is it qualifies as a logic gate, but this is basically what I used. It's similar to a D latch. It's kind of like it has a NOT gate. In the input of it, it has a clock. So this is basically set. Or no, sorry, this is set, and it turns the light on. And I can spam this set button, but nothing happens. Now I can spam the reset button, and it will stay reset. So yeah, it's basically an SR latch. So basically, it remembers what state it is in. So if this is all confusing, I'm sorry about that. I will put in the description that this is not really for. This isn't one of my regular videos. It is a special showing off one of my worlds. I may actually do other videos, redstone videos, tutorials, things like that. So yeah. Alright, well, I hope you guys all enjoyed this video, and this is Lucas, signing off.